Hello everyone, welcome to VMS class. In this video, we are going to learn about the Elastic Net Regression for predicting the car price. So we are going to take the same car price dataset which we have seen in the last video. But now I am going to explain this project by taking three different regression models. One is ridge regression. Second one is lasso regression, and third one elastic net regression. So these three regression methods are commonly used for regularization techniques. This ridge regression uses L2 regularization. Lasso is using L1 regularization. To take the advantage of both ridge and lasso, we are going to use the combination that is nothing but the elastic net combines both L1 and L2 regularization. So this project helps us to understand which regularization technique works better for car price prediction. Okay, now the very first step, we need to import the libraries. So for this, we need the pandas for data uploading and analysis, matplotlib for visualizing the graphs. Now, to divide the train and test splits, we are going to use train underscore test underscore split method. Now here I am going to import three regression models. One is the ridge, lasso and elastic net. I am going to perform the standard scaler that is basically used for scaling the dataset and taking three different types of evaluation metrics: mean absolute error, mean squared error, and R2 square. Okay, this is the same as the previous project, but additionally, I am going to show you Elastic Net in this project. Now, the next step is we need to load the dataset. I am taking the same car price dataset, and here I am going to read the dataset. Before going to execute this cell, so try to upload this dataset into the Google Collaboratory. Okay, if this file is available, then you can try to execute this project. Okay, now let us execute this cell. Now I have the data frame which contains 26 columns, and there are multiple rows are there. I am going to display only 5 rows here. Here I am going to check the dataset shape. You can see that totally we have 205 number of rows and 26 columns. Now check the missing values. So this is null method. It is going to check whether any missing values are there in the dataset. So missing values must be handled before the model training. Now all the columns are having the missing values 0. So that indicates that the data set is clean. So now we are ready to perform the training process. In this, we have totally 26 columns. Among that, some of the columns are irrelevant. So I have removed few of the columns and some of the columns are selected. And again, I am updating the data frame. Here, I am taking 22 columns from the original data set. Now in this data set, some columns are categorical columns. So I want to convert that categorical columns into the numerical columns using the one hot encoding. So for that, I am going to use the pd.getDummies method. For data frame, I am going to pass. Then after the result, I am going to store in the df underscore encoded. I am just displaying the top 5 records from the df encoded data frame. Now you can see that all the Boolean columns which is converted through the one hot encoding. Now out of this, totally we got 42 columns. So now the df encoded is the data frame now. So in this data frame, select the input features, df underscore encoded, drop the price column, The remaining all columns are given to the input features. Okay, that is assigned to X. Then price column will be taken to the target variable and that is stored in the Y. Now the split the data set train and test parts. So test size is 20%, train size is 80%. So train underscore test underscore split method is useful for splitting the data set. Now we are going to separate the data set into X train and Y train, X test and Y test. Okay, let us execute this cell. Now we have the train data, right? Now we need to convert the original data into the scaled data. So some of the features are having the different range. To make all the columns into the proper range, I am going to use the standard scalar. I have created an object for it. Then scalar dot fit underscore transform. So X train I am passing. So now this is the scaled data, X underscore 10 underscore scaled. Now, similarly, I am also converting to the test data. Okay, for the test data, you no need to perform fit underscore transform. Directly, you can use the transform method. Now, both train data is also scaled and test data also scaled. So basically, after the model training, when you are performing the evaluation, at that time you can transform this data. But however, so that is needed for the future purpose also. That is the reason I have converted in this stage itself. Till now, I have just performed the pre-processing. Now it is the task for performing the regression training models. Okay. Now three different training models I am training. One is the regression model. So you see the logic will be mostly same, training and evaluation. Only the methods are going to change. Now here we are going to use this ridge, okay, regression. I am passing the alpha equal to 1.0. So now the model is created here, ridge underscore model. So this model is going to train using ridge underscore model dot fit. I am passing the X underscore train underscore scaled data and Y train labels I am passing. Here in this, after training the model, ridge underscore model, I am going to predict the data by passing the X test underscore scaled. Test data I am passing to the model to predict it. The results I am going to store in the ridge underscore prediction. So try to remember these predictions are stored in the ridge underscore pred. And similarly, train the lasso regression. For this, instead of ridge, I am going to use a lasso. For this, you need to pass the parameters, okay, alpha value and maximum number of iterations. Now the model is created, lasso model. In this, I am going to train the model lasso underscore model dot fit. I am passing the scaled trained data and Y train labels. Once the model is trained, I am going to predict using the test data. Lasso underscore model dot predict X test underscore scaled. I am passing to the model. The predictions we are going to store in the lasso underscore pred. Okay, try to understand the ridge predictions are stored in a ridge underscore pred. Then lasso predictions are stored in the lasso underscore pred. Now, the main intention of this video is basically to train the elastic net. Okay, so now this is the main logic for training the elastic net regression model. So the logic is mostly same. You are going to use the elastic net regression model. You need to pass the alpha value and L1 ratio I am passing 0.5. The maximum iteration I am passing 10,000. Now the model is created here. Now in this line, I am going to train the model elastic underscore model dot fit. I am passing the scaled train data and Y train labels. Once the model is trained, I am passing X test scaled data to the elastic model for predictions. Now that predictions I am going to store in the elastic underscore pred. Now three different models I have trained on the same data set. Now let us evaluate the three different models using three different metrics. The first metric is mean absolute error, mean square error, R2 square. So these three values are same. Only the difference is instead of ridge prediction, we are going to pass lasso predictions and elastic predictions. The Y test labels are same. Now I am going to store the results in ridge underscore MAE, ridge underscore MSE, and ridge underscore R2. So here I am going to print the results, the MAE, MSE, R2 results. And similarly, I am going to perform the lasso regression evaluation metrics. Okay. Now you can see mean absolute error, mean square error, R2 score. I am passing white test and instead of ridge PID, now I am passing lasso underscore PID. The results are going to store in lasso MAE, lasso MSE, lasso R2. I am printing the lasso regression evaluation results here. And similarly, try to perform the evaluation on the Elastic Net model. Mean absolute error, mean square error, R2 square. I am passing the Y test and elastic predictions in this case. I am going to store the results in three different variables, elastic MAE, elastic MSE, and elastic underscore R2. Now I got these three models evaluation results. Even manually, you can compare the results. Okay, you can compare manually these three regression model results. But I have given the small logic to print all the results in a data frame. Compare all three models. So this table compares ridge, lasso, and elastic net regression. A better model you need to find out. How can you say the better model? So which is having the lower MAE, lower MSE, and higher R2 square. So here the small logic, I have created a data frame. So here model is one key value pair. So we have three values and MAE, three key value pairs are there. Okay, in this case model, MAE, MSE and R2. So totally four key value pairs. Now each one result I am going to store in the form of a list for a particular key. Now I am going to print the model comparison here, the data frame we have created. Okay, now you can see the results at one place, ridge regression, lasso regression, and elastic regression. So from the results, we can say that out of three models, this lasso regression is performing better on this particular data set because the MAE is lower, okay, even MSE is lower, and the R2 square is higher. So basically, students again may get some confusion here. Elastic net is going to combine the advantages of both, right? So elastic net regression should give the better results. Okay, so that is not actually the valid point. So it depends upon the data set, number of features, how overfitting is happen. So various factors will affect the model performance. But from this data set, we can say that lasso regression is performing better compared to the ridge and elastic net regression. Now here I am going to draw the results. Only R2 square I am printing. Okay, here I am going to display the bar chart between the evaluation results of R2 square. So even from the graph, you can say that lasso regression is slightly performing better compared to the ridge and elastic net regression. Okay, so that is the basic idea. I have compared three different models. And now coming back to the original project, the elastic net regression model I have trained. Now out of this, let us print the coefficient. So if you want to print the coefficient, you want to use a ridge model underscore coefficient. So that coefficients I am going to store, okay, in three different variables here. So here ridge coefficient, lasso coefficients. Okay, you can see that ridge coefficient I am going to store in a data frame. Then lasso coefficients I am going to store in a data frame. And elastic net coefficients also I am going to store in a separate data frame. Okay. Now combine the coefficients here. So all the coefficients I am going to compare and I am going to use the merge, okay, merge function, okay, of lasso coefficients dot merge of elastic net coefficients. So now that result I am going to store in a data frame here, coefficient underscore comparison dot head. Now you can see the top performing coefficient values. Okay, top five I am going to print. Okay, so ridge coefficients, lasso coefficients, and elastic net coefficients I am printing over here. And count the selected features. How many features are selected in each category? So in the ridge, how many features got selected? Lasso, how many selected? And elastic net, how many selected? So I am going to display here the selected features for each regression model. The ridge regression is selected 40 features, lasso regression is selected 39 features, and elastic net regression selected 40 features here. So here the feature selections chart I am going to display. Okay, how many features was selected for each of the regression model. Okay, just it is basically the analysis purpose. Now, a separate cell I have created to identify the top or important features according to the elastic net. Okay, we use the absolute coefficient values because both positive and negative are very important here. So here I am performing, these are the coefficient values, okay, which includes the positives and the negatives. But I have created a new column which is taking the absolute value. Absolute value means even if it is a minus, then it is going to show the positive value here. So just I want to display top features. Okay, that is the basic idea here. So in this case, I am going to display the top, okay, features. So which are mainly like affecting the performance of this model, or which is mainly related with the price. Okay, I have displayed the top features selected by the Elastic Net model based upon the coefficients I have selected. And here I am going to display actual versus predicted using the Elastic Net. So what are the graphical results? You can see the actual values represented with a blue color, and red predicted price are there. So if the distance between the blue and red is low, then we can say that a model is performing better. If the distance is very high, then it indicates that model is not performing well on the particular data set. And finally, I am going to perform the predictions on a test data set. So on the given test data, I am taking one sample, that is a sample car. Now, this variable should go for transformation because we have performed the scaling. Scalar data transform of a sample car. Now, this is the scaled value. Now, this scaled value, sample underscore car underscore scaled, it is going to pass to the elastic model for prediction. So that is the reason we are going to give the model name dot predict of the sample underscore scale. So this value we are going to pass. That result we are going to store in a variable predicted underscore price. Now here I am predicting the price, okay, and I am predicting the actual value, predicted value and actual value I am printing. So this is the predicted price approximately 26404, and actual price of that car is 30760. Maybe the slight error will be there, but that is the actual prediction predicted by the elastic net regression. So now you can see the conclusion here, the project insights. So we have performed Ridge, Lasso, and Elastic Net regression models. Those are compared together. And basically the Ridge uses L2 regularization and Lasso uses L1 regularization, and it performs basically the feature selection. So what Elastic Net model is going to do, it is going to combine both L1 and L2 regularization. So even though you have combined this L1 and L2, so still this lasso regression is going to perform better for this data set. The elastic net balances the coefficient and stringing and feature selection. All these going to be performed by the elastic net. Okay. So try to practice this. In this project, we have used the car price dataset to compare all the three different models, and even we have performed the some of the pre-processing techniques, which includes the encoding categorical columns. We are performing scaling. Okay, later we performed the training and evaluation of three different models and compared the performance of all the models. So where you can use this Elastic net regression, it is used in car price prediction, finance analytics, healthcare prediction, high dimensional data set, marketing analytics, risk prediction, business forecasting. In all these kind of applications, you can use the Elastic net regression model for training and evaluation. Thank you. If you like this video, please subscribe to our channel for getting more updates on computer education.